Okay, so I can tell you the answer in 2 seconds. It's equal to e to the power 2. There's a formula, literally. Say this is a, and it's e to the a. That's the congruent formula. It's really simple, but we're not going to use formulas here because you probably don't even have that formula on your sheet. And I only saw it because I saw it, but I'll do it legitimately. So let's just focus on 1 plus 2n then. Okay, well, if you say that's equal to e to the ln of 1 plus 2n to the n, then it's the exact same thing. I mean, because e to the ln, that kind of doesn't do anything, but it helps us think about something a little bit differently. It allows us to go like this and use the natural log property. And now we're here. And now this is going to start being kind of useful. Okay. So what this means is now let's just apply that limit here. So we could apply this limit, and let's move it. Limit is n goes to infinity, and we have n and ln 1 plus 2n. And if we do this, nothing too useful happens, right? So you need to actually kind of go a few more steps farther. So you'd actually see that this would be infinity times ln of 1, which is infinity, times 0, which is indeterminate, right? Indeterminate. So then what do you use? You need to use L'Hopital's rule, right? You need to use that. So if you don't remember, it means you divide up the limit into a numerator and a denominator, so a fraction, and then you take the derivative of both sides, and then you take the limit again. So let's go back a few steps now. So we're at e to the n ln 1 plus 2n, and we're going to rewrite that as e to the... Okay, so let's actually forget about the e right now, and just write it like this. And we're going to write this as 1 over n ln 1 plus 2n. And notice I didn't write the e because you just don't need it right now. You can break things into parts, and you don't need to show every single little detail. You don't need to keep writing out limit, 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 because obviously you're not doing a limit right now, so there's no point in even writing limit sign. Okay, well now this is what you do. So you put this arrow, you go L prime of h, and then you show that now you're going to take the derivative. So if you take the derivative, or let's just say d dn, d dn. So you're taking the derivative of the top and the bottom separately. What do you get? So you get 1, actually you get 2 plus n over 2. It's a negative, divided by 1 plus 2n, and then you get 1 plus 1 squared. Yep, that's the derivative. And note, the negatives do cancel. So what I'm going to do is we got blue and turn them into positives. Okay, so look at this. This looks really messy, so I'm going to grab it. And actually, I'll just go below. So now we're applying this limit logic. The limit, and remember, this is all to the exponential. Okay, this is a lot. There's a lot going on here, and we have these 2 separate limits. Okay, so we have 2n squared plus 2n, and we also have that. Okay, so this is our new situation that we're dealing with, everything right here. But obviously I do want to simplify it a bit, so I'm just going to focus on simplifying this down to something reasonable. The reason why I wrote this is just I wanted to show you what we truly have But remember, guys, if this is confusing, I'm just breaking it apart. So I'm not doing everything at once, because you can't do everything at once. But just focus on this for now, okay? So this is equal to, actually, let's just write, so 2 to the n squared times 1 plus 2n. Then this is going to be multiplied by n squared over 1. These can cancel, so we just get 2 to 1 is 2n. So, and look at this. This thing over here is exactly the same thing as all of that. So, it's not too bad anymore. So now we can focus on this limit, this exponential limit. So e to the limit, and then goes to infinity for 2, 1 is 2n. And as you guys can guess, what does this say? Well, basically, if you do let n go to infinity in this case, 2 divided by infinity is essentially going to be 0. So it's just 2 divided by 1. So this whole thing just turns in e to the 1, which is e to the 2. So yeah, there's a bit of work to do, and it can be confusing. I do recommend just searching up common limit formulas, but you can't do that, and if you don't have a cheat sheet, there's no point in doing it because you can't always have everything at hand. So I'll recap. What you do is you just rewrite the part that you care about as something else. That's usually what you do in limits. If you can't directly compute the limit, you either have to turn it into a different fraction, turn it into a different logarithm times exponential, or exponential times logarithm, something weird like that. What I'm saying is you have to keep it the same, but you can change how it looks. And if you change how it looks, then you can change the available operations you can perform on that limit. So it took a lot of manipulation to get this into this form here. And then from that form, we saw that, look at that, that's indeterminate. Okay, then we see, oh, use L'Hopital's rule, right? And then when we use L'Hopital's rule and we simplify everything, we get down to this, right? So that's the idea. Again, first thing, see if you can do it directly. And if you can't do it directly because you get an indeterminate form, then you need to think about a way you can rewrite it and then possibly use L'Hopital's rule. Hope that made sense.